have here polynomial functions and their graphs. Definition of a polynomial function. It says here, let n, and we're going to focus on that n, be a non-negative integer, and let a sub n, and then it goes down the line. Okay, and we'll talk about what a sub n is as well. Be real numbers with a sub n not equal to 0, meaning that given an equation, if our first term has, if it's a 0 there, it may not be a polynomial function. But it says here, this function defined by, and you see the equation, we're going to be putting some numbers in. This is a standard definition here. Okay, so off track for a second. This type of equation is something that the course that I'm taking now is we have to prove why this works. We don't have the numbers where I'm going to give you the numbers and all of that stuff. We have to go in the back end and prove why. They'll give us some rules and we have to prove this. Okay, so this looks very familiar as I'm talking about it right now. It's called a polynomial function of degree n. Okay, so going back to some things that we've done before, and we talked about leading coefficient, and we talked about degree meaning exponent. So I want us to focus on this first part of this equation where you have a to the n, a sub n times x to the n power, where n is our degree. A sub n is going to be, or is, our leading coefficient. We have here, it says the number a sub n, the coefficient of the variable to the highest power is called the leading coefficient. And we're going to talk about when you're asked to find the degree of a polynomial, you're looking for the degree, or we're saying the power or the exponent with the highest number. Okay? So we'll have some terms, and each term raised to a power may have a different exponent or different degree, but we're choosing the highest. And the one that has the highest exponent, we're going to focus on that and identify the degree of that polynomial, and with that, the term that has the highest power, the coefficient is called the number in front of that variable is called the leading coefficient. So we know what polynomials are. Okay, and it says here you have some restrictions. It says let n be a non-negative integer. Okay, an integer can be, when it says non-negative, we want it positive. Okay, and if we go back to the definition of an integer cannot be a fraction. Okay, so there's some things that really is telling you, okay, in, what it can and cannot be. But a polynomial function, we're going to look at what's a polynomial and what is not a polynomial. Polynomial functions containing square roots, variable or variables in the denominator, negative exponents, and exponents that are fractions are not polynomials. So if we see any of those, these conditions here where it's asking, the question may ask, is this a polynomial or not? And if you see a square root, and I'll give some examples, a variable in the denominator, a negative exponent or exponents that are fractions, it's not a polynomial. It's not a polynomial function. Okay? So, example 1, it says here, determine which functions are polynomial functions. Those that are polynomial functions, it says identify the degree. Let's look at example 1, and I'm going to place an example here. We have, let's look at the first one. F of x is equal to 7x squared plus 9x to the 4th. Is this equation, okay, is this a polynomial function? Okay, yes or no? Yes, it is. Because our powers, we have 2 and we have 4. Okay? But, and they're not to the negative power, it's not to a square root, it's not written as a fraction. Okay? So yes. Then it wants you to state, if we say yes, then what is the degree of this polynomial? 4, because we're choosing the highest. So since the degree is 4, our leading coefficient, I'm not going to have you write it here, but I'm just going to say it, our leading coefficient would be 9. So if you want to, you can write this 7x squared plus 9x to the 4th in descending order of power, where the first term is the leading coefficient, because you have that power of 4. Here we go, B. We have h of x is equal to x to the 1/3 power minus 4x squared plus 7. Is this a polynomial or not? No. Polynomial function, no. Because we have this exponent of 1/3, and we don't want a fractional exponent. Letter C. G of x is equal to 6x to the 7th plus pi x to the 5th plus 2x over 3. Is this a polynomial or not? That's why you say no. Yeah. Look at your powers. It didn't say anything about the coefficients. It is a function. It didn't say anything about, now, had this pi been raised to a power as an exponent, then we would say no, because we want positive integers. We don't want any fractions or decimals as exponents. But a coefficient, pi is a real number. It happens to be an irrational number, but it just happens to be a coefficient. That's okay. I said for your fraction, the variable cannot be in the denominator. If the variable is in the denominator, then it's not a polynomial function. It's a rational function. Okay, so we would say, yes, this is a polynomial. What is the degree? 7. Last example, we have here f of x is equal to 8x cubed minus x squared plus 2 over 3x. Is this a function, a polynomial function or not? No, because you have a variable in the denominator. So we say no. Anytime you have a variable in the denominator, it's a rational, function, rational equation. All right, so the second half of this, it says identify which graphs are not those of polynomial functions. So let's talk about this. Let's go to the second box here where I have polynomial functions of degree 2 or higher have graphs that are smooth and continuous. Graphs that contain only rounded curves with no sharp corners are smooth. Graphs that have no breaks and can be drawn without lifting your pencil from the rectangular coordinate system are continuous. So we only have two of these. So it says identify which graphs are not those of polynomial functions. Which one, the left one or the right graph? The right. Okay, so think about polynomial functions. You're going to have a curve, okay, a smooth curve. It can be quadratic or parabola. But remember, the higher the degree, the curvier that line is going to be. What type of equation is this? You remember? Absolute value. Okay. So I'm just going to circle this. Not a polynomial function.